Hello, everybody. What we are going to be doing today is introducing differential equations through these things called slope fields. So basically, the first question you may be asking is, what is a differential equation? So when we see the word differential, that basically means that it has something to do with derivatives, so to speak. And differential equations are an equation that relates one or more functions with its derivatives. So all of these are examples with differential equations. All of these are differential equations. And notice you may have both x and y on one side. And these are kind of like really nice differential equations because they do already have, the derivatives already separated out on one side. And what we are going to be kind of doing as we get later into differential equations is making it a goal to kind of separate the derivatives from the non-derivative stuff. So you may want to copy this discussion down here just to give you an overview of differential equations. All right. So what we're going to do now is I'm going to present some tips on slope fields after we go through an example already done with slope fields in Delta Math. All right. I want to, for example one, kind of start you with an example that is already complete because slope fields are best learned when looking at patterns. So we are going to call this example 1. And we're going to kind of just do this and discuss it. And I want to kind of show you the neat features of Delta Math in showing how the slope is computed. So you will always be given a differential equation. So this is an equation of the derivative or of the slope. And that's why it's called slope fields. And what we're effectively doing here is we have x and y coordinates. And Delta Math kind of gives you a pretty reasonable number. We don't want to overwhelm you, but what we can do is we can toggle over and show you how we are able to get you those slopes. So a few places where we may want to kind of get started here. I'm just going to go over, let's say that we have the coordinate -1, 2. And I'm just going to show you how they got the slope. So your x and your y coordinate are -1, 2. And they actually do kind of show you how they plugged in everything, but we'll just kind of do it organically. So like this is our x and y coordinate. So what we would do in computing the slope is we would put our x coordinate. So we go -1 + 1 squared over 2 squared. And that simplifies to 0/4, which gets us a slope of 0, which is why we have a horizontal line. And we can kind of see here as well that anytime we have a slope, so like one thing that we may notice here in the numerator is that when x plus 1 equals 0, or x equals -1, the slope is 0. And likewise, when my y values are 0, the slope is undefined. So I really do like just kind of like analyzing the equation and kind of looking at some of those general rules when we look at an example, and it can actually greatly reduce the number of computations that we need to do. All right, a few general tips on slope fields and doing them. So you want to basically plug in your x and y coordinate into your differential equation to estimate the slope at a point. And basically, slope is represented just like slope in Algebra 1. So a 0 slope is a horizontal line. Ooh, get it exactly horizontal here. A positive slope is increasing. So that's where we see, an upward slope. And then a negative slope, we're seeing decreasing. And then undefined is when we're dividing by 0. And that would be kind of like your vertical line. And I always suggest to kind of make the process a little bit shorter, you could be thinking about questions like, how are the slopes increasing or decreasing when the x value increases? How are the slopes increasing and decreasing when the y value increases? When is that slope going to equal to 0? And are you kind of observing, any other patterns? So with that, why don't we kind of look at an example on Delta Math together and create our own slope field. All right. So what we're going to do here in example 2 is actually create our very own slope field. And I'm going to kind of show you the long way and the short way at doing this. So this is example 2. So it says create a slope field at the given points for the differential equation dy dx equals to x over y. And change the slopes using the small pink circle. So we have our coordinates. So obviously at like 0, 0, that is a, kind of a divide by 0 undefined type of situation. Over here, we have the coordinate 0, 1. So at 0, 1, we would do 0 over 1, which is equal to 0. And likewise, we could see that if the x coordinate is 0, as long as the x coordinate is 0, our slope is 0. And I even like to, even look at the equation and think about those conditions. So I even make some rules to help me make a shortcut. So this is when x coordinate is 0, the slope is 0. So this could actually save us a great deal of time. All right. Another thing that we may notice is that anytime our y coordinate is 0, we get a divide by 0. Making the slope undefined. So I'm actually just going to take my cursor and create undefined slopes. If it lets me. And I'm going to try to make them as vertical as possible. And then I can kind of do the fractions for the other ones as well. So for 1/1, that is equal to 1. And then over here, I have 2/1, which is equal to 2. So you want to go a little bit steeper when you get that more positive number. And you'll just kind of want to approximate it. And then up here, we have 1/2. Which is going to give you something a little bit less steep than what we estimated our slope as 1. And then we have over here, our slope is 2/2, which is just 1. And actually that gives us, a completed slope field. And when you click submit, you can see how we did. And what they'll do actually is show you the actual slope with the red line, and the green line is the slope that you did. Now, it's pretty much, the same exact concept. We do give, slightly harder expressions, so you may want a good calculator, as you're kind of working on them. All right, example 3. These are slope fields that are already kind of given to you, and it's going to be your job to match the differential equation and the slope field. So I like to kind of make some observations here. I see undefined slope, so I see kind of those perfect vertical lines. And I see undefined slope, so I like to even like mark this up a little bit. So I say that slope is undefined. When x equals to 0. So what this actually kind of tells us here then is if we have like the y value equal to 0, that would not be, situation. So like when we have a y value equal to 0, we've got 0 slopes. They're not necessarily undefined. So I can actually kind of eliminate those. XY squared is kosher, and you're going to be defined for every, XY coordinate. So just by doing that, we were able to eliminate, 3 answer choices. Now, before I kind of click the submit button, I even like to just test it out and see, does the answer, make sense? So I'm just going to kind of choose a random point. So let's say I want to do 2, 1. And that's our X and our Y coordinate. And I'm just going to try that out. So I'm going to do a negative. It's going to be a 1/2. And sure enough, that does look like a negative 1/2 for our slope. So it does work okay. So I'm just going to choose that answer choice and submit. And the solutions do kind of show you as well how the solutions work. Let's take a look at another problem here. One thing that's really neat at this one is it really gives you kind of like a cool design, you know, almost like a whirlwind or something like that. And what I may want to do when I'm kind of doing a multiple choice, you know, rather than like tediously compute every slope, there's actually one that I can actually immediately eliminate off of the bat. And that would be this last answer choice, because we do happen to have undefined slopes. So we have that the slope is undefined. When y equals to -4, aka denominator is y plus 4. And what we may want to try and do also is think about, you know, when those slopes are 0 as well. And we can see that the slope is 0 when we are on the y-axis. So now this leaves us with a few answer choices to kind of muddle through and think about. So we may want to try a point. So like after we've kind of eliminated a few answer choices, we may want to see what happens if we have 6, 6. So I'm just going to try, you know, 6, 6. So on this first one, I have a 6 squared, and then I have a 6 plus 4. So that's going to get us to a -36 over 10. And when we get that, that's about a -3.6. So indeed, we do have a negative slope. So this is contention. On this one, I'm going to do the 6 over 6 plus 4 squared. And I'm going to have, for that one, it's going to be 6 over 10 squared, which is 6 over 100, which is a positive slope. Clearly, we do not have a positive slope, so I could actually eliminate that answer choice right off of the bat. And then the last one is I have a -6 over 6 plus 4. So that is a -6 over 10, or a -0.6 slope. So this one actually is looking like it could make some sense. And I'm actually just going to try, that's kind of another example. We could see maybe what happens if we choose a, like, let's say we did like -6, 6. And let's say I wanted to try that first equation. So if I were to do that, I'd have a negative sign. I'd have a -6 squared for my x. And then I'd have a 6 plus 6. So this would get me to a -36 over, and it's a 6 plus 4, I should say, 10. So that would still get you a negative slope. So the square one also is not working out. So I do like to kind of try out a few points and take them for a test drive as well. And even with just 2 simple computations and kind of making that general rule about like the undefined slope, we could actually make a nice process of elimination. And maybe I'll just make sure that the -6, works on the one that I chose. So I have a negative of a -6 over 6 plus 4. So that's a +6 over 10. And that happens to be a slightly positive slope. So let's choose that answer choice. And we are good. So this type of exercise here, it is really helpful to kind of hone in on some patterns, maybe make some observations of the rules of different equations. And this will actually get you exploring differential equations at a very visual level.